Hello and welcome to day 6 of the Advent of Code 2021. Today is all about fish and their procreation. The interesting thing about this puzzle today is that it's about exponential growth. So what we have to do in today's puzzle is just the following. So we have lanternfish that have, so to say, an internal clock, an internal timer that dictates at which point they procreate, creating one new lanternfish. The whole concept of like sex and stuff is taken out of account. Sex in a sense of a gender. So you don't need two or whatever. They can just procreate by themselves. So they're I guess I don't know what the term is, but you get what I'm saying. And you can just make a new fish by themselves. So the goal of the puzzle is that you are given a list of fish, and with the numbers here, comma separated, representing their starting conditions in terms of these internal timers. So what do these values mean? Just quickly before we get started coding, when this reaches 0, so when a day ends, so to say, and it reaches 0, day in this simulation that we're gonna write now, then all the fish that have a 0 in their internal clock create a new fish. Right. That new fish always starts with an internal timer of 8. And then just what happens is that every day that we simulate, we decrement each counter from every fish by 1. Of course, making sure that all the one that reached 0 in that day, that they create a new one with a starting counter of 8. Otherwise, if a fish reaches 0, they don't go back to 8, but instead, that's what's mentioned here, they go back to 6. So a fish reaches 0 has two effects. First one being itself goes back to 6. And then again, if you simulate further days, after another 7 days, so to say, it creates another fish. But the side effect also is that when it reaches 0 and only goes to 6 itself, also creates a new fish that starts at 8. So you see the effect right here. On this day, or rather on the first day, we had one that had 1. Then there's one that's 0. So because this reached 0, we create a new fish. This is this one with number 8. And the fish itself continues with 6. So continuously, all these counters go down all the time, creating more and more fish. And as you might imagine, or as it actually mentioned in the beginning of the puzzle right here, this is exponential growth, because the fish just, you see also the curve here getting longer and longer. They multiply very quickly. So the point of the puzzle right now, or at least of the first part, is to simply determine how many lanternfish there would be after 80 days of simulation. So let's jump right into the code and figure it out. So this one has the big difficulty that there's this exponential growth, right? Due to two reasons. The first one is that if you model it a bit naively, let's say, by making, let's say, every fish being an object in memory, you will just simply run out of memory at some point. If the input is large enough, input being this value, like how many days do I want to simulate. Since then, at some point, you have so many fish objects in memory that there's simply not enough memory, even if you give it a lot of memory, because it's exponential, right? So at some point, it's ridiculously high. And the second problem that you can run into quite quickly, and that's the one I mainly want to focus on in this video, is that your numbers might not be large enough. So in terms you are not familiar with this at all, I will suggest Googling around a bit, but in essence, the only thing that's important to know, of course, and I presume you'll know that already, there's different number types, of course. So we have integers, longs, unsigned version of that, a short also, for instance, with the main idea that each type can store a different range of number values, with the idea that it takes more or less memory. So if we know, okay, we only need a very small range of values, we take one that only supports less values, but also having a very small memory footprint. And then if you, so by default, you would take like an integer usually, which supports quite a lot of numbers, but also not insanely large ones. So if you need something more, you have to take other types. And if you want to save even more memory, you could take a short, for instance, that has less range, but also less memory footprint. And then the unsigned versions, if you don't know what that is, so we have an int, but also a uint in Kotlin as well as in many other languages. Let's not type it here. Uint, like that, and int. Unsigned meaning that it only supports positive values. So unsigned in the sense of there's no plus or minus sign at the beginning, saying if it's negative or not. There's essentially only a plus sign, meaning that you don't need a sign at all. So you can only support positive values, which means on the other hand, since you miss out on everything below 0, you can have twice as many values in for the same memory, right? So the values you do not need to support below 0, negative, you can just append at the end to the usually highest integer, and so now your integer supports twice as many positive values, while not taking any more memory. So yeah, that's the basics that are necessary to understand the rest. The rest then is honestly pretty straightforward. So let's get going right away. If we look at solve part 1, what I did right here just is firstly a parse input function that simply does the following. So our input, as you already saw, looks like this. We simply have a comma separated list with the internal starting timers of all the fish. So obviously all we just do is split by a comma and then map everything to an integer, since we know it's going to be integers. So we just have a list of integers returned. That's very easy. Now comes the interesting part, simulate days. So what I do right here, I'm going to go from top to bottom, so don't worry, is the following. So I decided against, and honestly I think it's not even possible doing it not like that, against having each fish being represented by its own object. Because of course what we could do, right, we could here say data class fish, I don't know, var timer int, and then we could mutate this over time, going down and down and down, and then we could spawn a new fish out of this. Let's say it has an age method or something, and it returns a nullable fish depending on if it procreated or not, something like that. Decided against that because that would mean that if the input here of the days, which is the second argument here, is large enough, we would very, very quickly run out of memory, because we need to store millions, billions of fish object. So instead what I did, and this is the thing to understand at the beginning, there's simply a hash map that is of int to ulong. Why ulong? In a second, or pretty much I gave the reason already. So the integer in this case just symbolizes the timer. So we just simply map how many fish are there with this timer value. So if we look here at the example again, how many fish are there that have a 1, which are quite many, and the answer to how many is the values, or are the values. So you can see also here fish to amount. So this is the internal timer value. So our map will only ever have 8 values, and the value then here is how many are there with this internal value. And then you already can tell why a ulong. So just as an unsigned integer, is what I just explained. Same exists for long, so we can have very, very large numbers in this thing, which we do need in case we want to simulate very many days. So all I'm doing right here is I created an extension function that is called countBy. All this is doing, it's honestly one that I wrote a couple of times in the past already because it's pretty useful. It does a group by with a selector. So regular group by, if you don't know what that is, you give it a lambda expression and it will try to create a map for you with whatever is in this map as the keys, and then all the values that match this selector as a list of values. So you could essentially say, in this case here, make me a map of 1 as the key, and then all the ones in a list that match this key. So you would have a map that is literally 1 as a key and then a list of all the ones as the values, which in this case is super useless because we're only interested in how many ones are there, not the actual objects of the integer, because yeah, that is useful for other things, of course, where you have more fields or something. In this case, it's obviously not. So what we do want is counting. So what I simply do then is I map all the values of the keys to simply take what is here now, the list of values. I cannot see it nicely. Here we go. A list of t, so a list of int in our case, and we simply count them. So that therefore we return a map from k, so the key in this case is an integer as well, to integer. So we simply say how many ones are there, and then it says, I don't know, 10,000 or something. So that's that. Important thing we need to do now still, of course, since we want a ulong, is I simply map this and convert it to a ulong. I didn't make that count by already supports anything else but integers, simply because the input here is not large enough by far to overshoot the range of an integer. Therefore, simply converting it here is fine enough. Of course, we need to do it here though, because later on we need this map and then the values will grow over time. Therefore, start out with the ulong to begin with. Right, let's look at the actual algorithm, which you see is actually pretty short. There are probably nicer ways to do this, but I think this is one that is at least very, very straightforward to understand, in my opinion. So what works pretty well here is the repeat function of Kotlin. It does literally what it says. You just repeat the lambda that you give it here as many times as the argument. And then you receive here as the argument, let's say in the lambda, you receive the current index. So this would start at 0 all the way until whatever days were given here. Right. So the important, interesting thing is that happens is essentially this flat mapping here. So what I decided to do, I will explain it first and then go through the code, is that I figured it's easiest that at each day that we simulate with this repeat here, that I essentially create this map that we have that maps how many fish we have with this current state of the counter of the clock to the amount, that we recreate this every day, the map, because of course the things changed. Another option, of course, would be to make this map mutable and then do it in the correct order, such that we check like, hey, which are now reach 0, then we override the value of 6 for the ones that are now like going back to 6, while also keeping into account that there were probably already other fish that were at 6 currently, so you somehow need to merge the values together, stuff like that. Didn't like that, also because then the map has to be mutable. Instead, I figured this map has very small footprint already, since we know how many keys it can have at any given point in time. So recreating it and throwing away the old map, I think, was easy to understand, less error prone, and also, yeah, the memory footprint is minimal. So all I'm doing here is I map over the current fish to amount hash map, receiving here the key and value. So you see here, this is the time until procreation. I guess the variable is very descriptive, and the current amount of fish with this time until procreation. So all we do is, if this is currently 0, meaning that now they should procreate, we create one fish that starts with a 6 in this clock, 2, creating a pair, the current amount of fish that have this, meaning that for all the fish that now reach 0, not for all the fish, for the key in the map that is now 0, we create a new key later on. We'll see that in a second. That is now starting at 6 again with the same amount, obviously. So all the fish that now reach 0 will automatically go to 6 afterwards. Therefore, we can do this nicely. The second thing we'll do, and I will run this code in a second in a debugger, so it's a bit easier to understand what's going on. The second thing that we of course have to do is that the ones that did reach 0 also have to create new fish. And since obviously all the ones that reach 0 will create the same amount of fish, 1 for each fish, we can also again say we need the same amount that were previously 0. The only difference is they start with 8, since this is just given by the assignment. So all I'm doing here is I create a list of, so rather this mapping operation returns all the new key value pairs, and that's exactly what these pairs represent from simulating another day. So let's quickly look at the else before running it. In the else case, that's very easy. So if they did not procreate, we can simply say, okay, all the fish that had whatever value this was, let's say 4, now have 4 minus 1, so 3. But of course, they also don't change in amount. So we return only the singleton list. So in this case, there's no extra fish created since, well, they didn't procreate. Then this is flat mapped such that you then have a flattened list of pairs. And this is the point where I think it does make sense to run this and see what's going on there. Let's take a look right here. So let's first look at this map, so this is a bit easier to understand. So we would here simply have the current internal clocks of the fish. This is literally just the first day, or the 0th day, if you will. So we see that there's 205 fish with a 1 in the internal state, which makes a lot of sense looking at the input. There are very many 1s in here indeed. So that could well be. And, well, all the other fish. So what would now happen is if we simulate the next state, this would go to 0, meaning that they would create new fish. The other thing we cannot see here very well, and that's why I will put it into a variable first, is what the result of this flat mapping is. So let's put a breakpoint here instead and take a look at this. Because I feel like this is a bit confusing to understand potentially. So the result of this simply is now after the first day, the key value pairs of this. On the first day, it's not super interesting yet, but what you probably notice is that when we go to the second day and there are some fish that will now procreate, we have a case where at some point they can be like keys that appear twice. So here's also not the case yet, but if we go one further, then at some point we will have some keys that appear twice in the list, like now. So here we have 6 and 6. This can happen, of course, since now is the first time that fish that were created 2 iterations ago, 2 days ago, they started 8, right? So they will reach 6, while some others that procreated in the last iteration, they also reset to 6, right? So at some point at the number 6, you will get like clashes, and now also at every other number after this, because, well, they go down together. So the only thing that now happens in this thing right here is that we need to sum these together. That's all that needs to happen. So of course, there's fish that we newly created and there's fish that were already existing. Both are now at a value 6, so we essentially need to just sum the 205 and the 27 together because they're both valid number 6 fish, blah. And that's precisely what happens here. So we just group by the first element in the pair, the key, and then also we say throw away the first one for the value, such that after this step we would simply have a map from the from the key to all the list of these ones. So let's also put that into its own variable. Nope, not into a method. Yes, and take a quick peek at that. And then I think the last step is already pretty straightforward. So all we get now in the group by, as you can see, is a map of integer to a list of these unsigned longs. So this would simply look like this now. So again, when we go further until the point where the first fish reached 6, we now have a value here that has multiples. So we have our 205 and our 27, the same you saw previously. And then if we go further, this always moves down a bit, and at some point we have more and more and more that clash on the same key. So all we do in the final step, and then literally that's already it, we simply say map the values by summing together all the things in these lists here, since they're both, as I said, valid number 6 fish, so we can just sum them together. We do here once.sum, and as the final step we simply override our existing map to now be this new map, since we essentially folded everything together in some way, you could say, such that this is now the new state. So if we go here now, you would see that our fish to amount used to be, let's have a look. So there were 23 fish that now reached 0. So we would expect that once we override this, there's 23 more fish that have that are at 6, and also 23 more fish that are now at 8. So at 8 should be 23, but at 6 should be 23 plus the ones that are now at 7, since, well, they will go to 6 afterwards, right? So there should be 50 in number 6 and 23 in number 8, if I'm not mistaken, if my math didn't let me down. And indeed there's 50 in number 6 and 23 in number 7 and number 8, I'm sorry. And since we now repeat this just all the time, you'll see that at every iteration these values change, but the main effect that you'll see is that we get more and more and more and more fish. So in all of these buckets, so to say, the fish just grow. You see we never exceed 9 in the size here of our list, of our map, since of course all the keys stay the same, but we get more and more fish. So now at every iteration I decided to print out here how many fish we currently have, and you see it grows quite immensely. So finally, after 80 days, we have 300 and something thousand fish. Right, this was part 1. Let's now look at part 2. So part 2, again, similar to yesterday, is pretty straightforward change, where of course quite some things can go wrong. I pretty much elaborated at all of them though already. So the only thing that changes is now the question is how many lanternfish would there be after 256 days. So in this implementation, all we can do is simply say, instead of days is 80, days is 256, the rest is exactly the same. And we can run that as well. And with this implementation, it'll work just fine. So the trickiness in this case, you see the numbers insanely large though due to the exponential growth. So the trickiness in this one, I pretty much explained at the beginning already, was simply, well, not so simply necessarily, but was that either if you model the fish as objects, you will simply run out of memory at some point, because one cannot hold that many objects in memory if the footprint is not like very, very minuscule. Or if you didn't choose a number type that is large enough, you would get some super weird values here. Let's quickly look at it if it didn't make sense yet, why or what exactly would happen here. So if we would instead say that this supports integers, and here we just say return an integer. This is all the change needed, right? Because the rest is generic. So the sum function, there's one for ulong and also one for int. So if we run this instead, which is an approach that seems reasonable to begin with, right? And it, I think, does actually work for the initial solution. Let's see. Yeah, so here it gives the correct result. You can see right here. So of course this is on purpose by the creator of Admin of Code. So the first one still fits nicely into an integer, so that's all good. But only the difference from 80 to 256 with exponential growth means that, let's go to day 80 actually in the second simulation, that only like a few dozen days later we reach a point where the numbers get like super large, and then at some point we do reach the point that this will simply not fit into an integer. And then the effect, you probably know, in case you don't, it's the following. It will start to like wrap around and continue in the negative range. So apparently here at day 180, this doesn't fit anymore. So instead of going higher, because the integer does not allow for higher value at some point, it will continue at the lowest negative value and then go up again. And then you see this effect. So we start with a very negative value, go higher and higher and higher until we're positive again, and then this cycle just continues all the time. With obviously the problem that already after day 180 we have a value that, yeah, this makes no sense. But even worse, due to the way that it cycles around, this is just completely garbage at the end here. So that is simply why you have to choose a number type here that supports large ranges of values, which ulong does. Other languages have similar concept for this, or even you have in some languages types that have just arbitrary length. Right, that's it for day 6. If you have any questions, please drop them in the comments. I'll be very happy to answer them. If you haven't yet, I'd be very happy if you join the leaderboard that you'll find in the description of this video if you're also participating. And finally, yeah, thanks a lot for watching. Consider subscribing to the channel, and I see you tomorrow. Tschüss.